Today we're looking at Chapter 6, which begins on page 358, but we're actually going to go through the steps to success in Level 1, which is on page 377 and 378. At the bottom of 377, it tells us to open a new workbook and basically create these columns and these rows, but I have put that in the Learning Management System under Chapter 6 data files, so you don't have to build that from scratch. If we turn to page 378, number 4 says using the information provided for the options. Basically, we want to borrow money to do something with our business, and we're trying to figure out what's the best way for us to borrow that money. It says assume that the payment period duration will be used as the compounding period and that payments are made at the end of each period. That has to do with the payment function. If we look at our function wizard and say PMT, that's our payment function that tells us what the payment is, and notice the different things. The rate is the rate per period of the loan. In other words, if you are making payments every month and you have a 6% interest for the year, then you would divide that by 12 to get your monthly interest rate. Then the number of periods would be how many payments are you going to make for the loan. So if it were 4 years monthly payments, that'd be 48, 4 times 12. And then the present value is typically the amount you borrow. That's the present value. The future value, you're wanting to pay that down all the way to 0. And notice you don't have to put anything there. That's an optional parameter. Notice the type of payment. If you put a 1 there, you're making the payment at the beginning of the period. If you put a 0 there, you are making the payment at the end of a period. It is assumed to be 0, so you can leave that blank. What that means is typically when you borrow money, you pay in arrears. After the first month goes by, your payment that's due the 15th of the next month is to pay the interest and principal on the previous month. We're generally going to assume we're paying at the end of a period. Number 4, option 1. We're looking at somebody who's giving us this option. They have proposed a campaign costing $65,000. This agency will accept full payment over the next 2 years in equal quarterly installments of $8,500. For this option, you need to calculate the annual interest rate. We're going to be making payments. The payment per period would be $8,500, wouldn't it? And it's going to be for how long? 2 years. So this would be 2 for 2 years. The total that we're borrowing, the present value, would be $65,000. Future value, of course, would be 0. We're going to pay that off in 2 years. And the number of compounding periods per year, this is done in quarterly payments. So what would the number of periods per year be? 4. That's exactly right. And one little thing, this payment is going away from us, so we're going to make that negative so that everything works out fine. Now we want to find the annual interest rate, and that's going to be the rate function. We could look up financial functions, and all of these things would be in there. There's our rate function. It says it returns the interest rate per period of a loan or investment. So that's the rate per period. We probably want to know the annual rate, so we're going to multiply that by the number of periods per year when we finish out the rate function. So let's put that rate function in there. And it says the first thing we need is the number of periods, the number of payment periods for the loan or investment. Now, how would we find the number of payments? The number of periods, if we're borrowing for 2 years and we're paying 4 times a year, then it's going to be this thing times that thing, isn't it? And that's always going to be true. So I'm going to click in C3 and multiply that by the number of years. So we're going to be making 8 of these payments. 8 of those payments would be 8 times 8,500, wouldn't it? So that would be, what, $68,000? So we want to see what interest rate are we paying, because we're paying it off pretty fast. All right, so that's our first argument. The second one is the payment. This is the payment made each period, cannot change over the life of the loan or investment. So there's my payment right there. What's the third thing? The third thing is the present value. That's how much I'm borrowing. So there's my third thing. And it's telling me that my interest rate, if I'm paying down to 0 and paying in arrears, it's telling me my interest rate per period, remember, is 0.01. So it's about 1% per period. But this says annual interest rate, doesn't it? So we're going to have to take that rate and do what with it? That's right. We're going to want to multiply that thing by the number of periods per year, right? So here's what we want to do. For the number of periods, we want C3, this 4 times a year, times E3, which was the 2 years. For the payment, we want what's in F3, which was the $8,500, negative. For the present value, we want the amount we're borrowing, which is G3. Once we get that rate, that is the rate per period. And we have 4 periods in a year, so we're going to want to multiply that rate times this 4, and that should give us something around 4%. So it looks like our annual interest rate to the nearest 100th percent is 4.05%. Notice that every one of these things was given to us in the problem. This was our only formula. So I'm going to go ahead and highlight that in yellow just so we know that's where the formula is. Now we're looking at option 2 on page 378 of number 4. It says Hicks and Bradshaw has designed a campaign for $55,000. It will charge 6.5% annual interest rate, fixed monthly payments for 18 months. So they're charging us $10,000 less, but their interest rate is 50% higher, and we have to pay it off faster. But we want to evaluate all these and see what's our best option. So where would we put the $55,000? That would be our present value, wouldn't it? Our future value is going to be 0 again, always. 6.5 annual interest rate goes right here. Monthly payments. So what goes here under number of compounding periods? That would be 12, wouldn't it? Monthly payments. And how long is the loan? 18 months, which is how many years? Yeah, 1.5 years. So now we have to figure out the payment, don't we? All right, for that we use the PMT, the payment function. So let's find that. There's PMT. It would be under financial, or we could just type PMT and it would go to it. And notice these things all need the same parameters, don't they? It's just that one time we're solving for this one and given the others. Another time we're solving for that one and given the others. So rate is the interest rate per period. Well, that rate per period is going to be this annual rate divided by the number of periods, isn't it? So I'm going to divide it by C4, and it says, here's your monthly rate, 0.005, which is about 0.5%, and if you multiply that times 12, you get about 6%, but it's bigger than that, so we're in the right ballpark. That's our first parameter. The number of periods, that's the total number of payments for the loan. So that would be this thing per year, and what would we do to it? We'd multiply it times how many years we're borrowing it, wouldn't we? Now our third parameter is our present value, which is right here. Future value again is 0. The type is at the end of the month, so we don't need to fill any of that out. And notice it says, if these numbers that you've given me are calculated, I'm going to give you back a payment of a little over $3,000 a month. So it says there's your payment formatted to the nearest dollar. Option 3 says Ad West Incorporated has proposed an ad campaign costing $44,000. This agency is willing to accept semi-annual payments of $9,200 until the campaign is paid off. Let's talk for a moment about these two prefixes. How many wheels are on a bicycle? How many parties does it take to have a bipartisan agreement? Takes 2. How many legs does a biped have? 2. So bi means 2. How much of a circle is a semicircle? It's half, isn't it? Have you heard the term for an 18-wheeler, a semi? S-E-M-I, a semi-truck. It's half truck, half trailer. So an 18-wheeler is half truck, half trailer. That's why they call it a semi-truck. So bi means 2, semi means half. If I get paid bi-weekly, that means I get paid every 2 weeks. Okay? If I get paid semi-monthly, that means I get paid every half month. If you take a journalism course, they will say, do not ever use these words because nobody is sure what they mean. Yes, we're having our biannual meeting, and nobody knows, does that mean every 2 years or does that mean 2 times a year? Biannual means every 2 years. Semi-annual would be twice a year. So they would say, if you're going to say bi, just say every 2, whatever it is. And here we would say, not every half month, we'd say twice a month. Option 3 says semi-annual payments. So how many is that a year? That's 2 payments a year, isn't it? Every half year, semi-annually. And they're going to charge us how much? 6.25 annual percentage rate. And the whole campaign costs $44,000. And do they tell us what the payments are? $9,200, and that should be a negative, shouldn't it? And now they say we need to calculate the duration in years that will be required to pay off this debt. How long is it going to take us? Hey, this is pretty cheap as far as the total amount, but if it's going to take us 30 years, I bet we'll be paying back a whole lot more than these other options. So to find our loan duration of years, we're going to want to find the number of periods. How many times we're going to be making this payment? And then, because we're making 2 payments a year, we would take this and divide it by 2, and that would tell us how many years. So let's use that NPER function. That's number of periods. And the rate, again, this is the interest rate per period, isn't it? So it's this rate. And how would we get the rate per period? We're going to want to take that annual interest rate and divide it by the number of times we make that payment, the number of compounding periods. So we're paying 3 1/8 each 6 months, which equals 6 1/4 per year. Our payment is this $9,200. Our present value is this amount. Our future value is 0 again. Actually, I don't have to put that in. I'll just put it here. So this tells me 5.3 is the number of periods, isn't it? But I don't want the number of periods. I want the number of years. This says I'm going to have a total of 5.3 periods. But I want to know how many years that is. 6 periods would be divided by 2, 3 years. So this is a little less than 3 years. So I'm going to take this and divide it by the number of periods per year. And that tells me to the nearest tenth of a year, it's 2.6 years. That's the only formula in that row. And again, we're paying it down to 0. Future value of our loan should be 0. Option 4 now says that Johnson, Bellevue and Associates has shown the marketing group an excellent campaign that will cost $1,500 a month for the next 3 years. This agency's payment terms are based on an annual interest rate of 5%. For this option, you need to calculate the initial value of this advertising campaign. So they give us $1,500 a month. Where does that go? That's our payment, isn't it? So that should be negative $1,500. And when they say a month, what does that tell us? That tells us the compounding periods, doesn't it? It's going to be 12. Do they tell us the interest rate per year? That's 5%, isn't it? And do they tell us how long the loan is? 3 years. So they want us to figure out, okay, how much are we borrowing? And that would be the present value. And guess what? There's a present value function. All those parameters in the payment function have their own functions that we can find if we already know the payment and the other parameters. So we want the present value here, which is PV. And we just fill in the numbers. The rate, again, is the interest rate per period, not the annual rate. So it's the annual rate divided by the number of periods. The number of periods is this. I'm sorry, number of periods per year. We want the total number, so it's this per year times how many years? We're going to be making 36 payments. Our payment, they already told us, was this much. And now we assume we are making the payment at the end of the period and we're paying it all off down to 0. And it says basically you're borrowing a little over $50,000. And that's the formula in that row. To determine which option is going to be best for us, first of all, it would be nice to know how much are we having to shell out every year. Can our cash flow handle that on a yearly basis? So number 5 says, in an adjacent column, calculate the total yearly payments required for each option. So to find out our yearly payments, we would take the payment per period and do what with it? Yes, we would multiply the payment per period times the number of periods in the year. This will be our total yearly payments. So we're going to say take this payment per period, multiply it times the number of periods per year. We could leave it positive or we could make it negative, just depending on how we want it to look. And let's copy that down. Notice it is negative because this is negative, but if we wanted that to be positive, we could just stick a minus sign in front of this and it would make it positive. But I'll leave it negative, and we'll copy that formula down by double-clicking the fill box. And this says here's how much we're paying out every year. Number 6 says to format this thing nicely, and it's already been formatted for us in the file that we started with. Number 7 basically says if you were trying to minimize your yearly outlay, what would be the best way to go? Well, it would be the least money per year. That doesn't mean it's the least dollars out the door, but that's what they asked for. So we're supposed to type a little comment. I'm going to say option 4 would minimize the yearly outlay. And they want us to highlight that in pink